We're going to work on our test review for Unit 8, Quadratic Basics. And there's a part of the test review that we're going to do together. And then there's a part of the test review that you're going to do by yourself on your own. So let's work the part out that we do together. The one thing about having this on video is you can stop if you need to listen to something again. You can stop and write in the stuff that I have written so that you can catch up if I go a little fast, or you can re-listen to something. You can also fast forward if you want to work, if you want to pause it, work on the next problem, then fast forward to the answer just to see if you got it. That's another way you could use a video. So this way you've at least heard me discuss the different things. The first thing we did in this unit is we multiplied. We talked about something called the FOIL method. Multiply the first times the first, which is x squared, because you add exponents. The outer ones, the ones on the outer edges, that's x and -6. It's -6x. Then we did the inner ones. +6 times x is +6x. And then the last ones times the last one, +6 times -6 is -36. There's always some like terms, usually in the middle, and those, if they have the same letter and same exponent, we can add, but we only add the numbers in front. Turns out -6 plus 6 is 0. So my answer for number 1 is x squared minus 36. Number two, the easiest thing to do is to know that that really means you have two parentheses exactly alike. So what I usually do is I just mark this one out and I just draw me another set of parentheses and I'll put the same thing in them. In this case, 2x minus 1. And I'm simply going to do the FOIL method. 2x times 2x, 4x, add exponents on your x's, it's x squared. 2x times -1 is -2x. And then when I do -1 times 2x, and -1 times -1 is +1. My like terms in the middle, this time I can add those. -2 and another -2 is -4x plus 1 at the end, 4x squared in the front. 4x squared minus 4x plus 1. The last one, FOIL method again, or a lot of times I like to call this the lobster claw. First times the first, I get 2x squared. 2x times 3 is +6x. -5 in x. And then -5 and +3 is -15. Now, my like terms are in the middle. I can add as long as I have the same letter and the same exponent. 6x minus 5x is plus 1x minus 15. 2x squared in the front. Okay, that's my answer. Okay, that is supposed to be an x. Find the area. We've done these several times. These are not hard, but they do take some time. So what I'm going to do with this is if I want to find the area of the shaded region, so this part is shaded, I'm going to have to find the total area of the whole big part, right? The whole big part. That would include everything. Then what I'm going to do is I'm going to find the area of the smaller one, and then I'm going to subtract it away. So I'm going to end up, to find the area of the shaded, I'm going to take the area of the big and subtract the area of the small. All right. So the area of the big, subtract the area of the small. Okay, the big triangle, or excuse me, the big rectangle is 2x x plus 6. So 2x plus 1 on one end times x plus 6 on the other one. That's what I would do in order to find the area. Make that a little neater. 2x plus 1 times x plus 6. And that would give me the area of the big. 2x times 2x is 2x squared. 2x and 6 is +12 with x. 1 times x is 1x. And 1 times 6 is 6. 2x squared. Adding like terms is 13x plus 6. So that's the area of the big. Now I'm going to do the area of the small. And this one is an x length inside times a width of x and a length of x plus 1. So x times x plus 1. Not two sets of parentheses. This time I only have one set of parentheses. So I'm going to distribute the x. X times x is x squared. And x times 1 is x. Now, that makes this the area of the small. So if I rewrite the area of the small behind the area of the big, I got to remember that in order to find the area of just the part that's shaded, I'm going to have to subtract away the part that's in red. So remember, if I do the part here in red, right? If I do that, that's the part in red. The whole stuff, the whole container is in blue, and then I have to subtract. There is something I got to remember. When I subtract, I do need to keep parentheses around my two parts, especially the one after. So I'm going to make this a plus, and everything in parentheses, I got to remember to change the sign. Okay? So now, 2x squared plus negative x squared is 1x squared. 13x and plus a negative x is plus 12x. There's nothing else to add to 6, so plus 6 is in my final answer. So the answer for the area of what's shaded is x squared plus 12x plus 6. All right, that was our review of multiplying. When you multiply, everything in one parenthesis has to be multiplied by everything in the other parenthesis. Number 5, factor. The first thing we ever did learn to factor was we learned to factor the GCF, which stands for greatest common factor. That means I want to take everything I can that's greatest away from every part I have. Sometimes we have a greatest common factor, sometimes we don't. Number 5, I noticed that I have an A in the front part and an A in the second part. Just to go back and refresh, that's really A times A, that's really B times B, and over here, this is just an A. All right, and this is separated by a plus sign. So I can actually ask myself, what's in common? Well, A is in common. How many A's can I take away from both parts? Well, I can take one away, and over here I could take one A away. So that makes the common factor A. So that's my GCF. So I'm going to write it out front. When you do GCF factoring, it's one set of parentheses, and I always encourage you to build your frame. I have two parts in my original problem, so I'm going to have two parts left inside my parenthesis, and the plus sign is in the middle. Now, I've always said DS means if I ever have numbers, I don't have numbers in this one, but I would divide the big numbers, and I'm going to subtract the small exponent numbers. Okay. So if I take away an A from A squared B, if I take one of these A's away, okay, then what's left is one of the A's, so A. I did not have a B in common, so I didn't take any B's away. So B to the second is still in the first part. Now, if I take A away from A, I do not have any letter remaining. So there's no A here. But do keep in mind, when you're factoring, you're doing the opposite of multiplying, so you are technically dividing. Okay? So that really means I have divided out an A. So an A divides into A, subtracting exponents. There is a 1 that's left. Remember, how do you check your answers to see if you're right? Well, what you do is you're going to multiply A times AB squared. And you add your A's. That would give me A2B squared. And then A times 1 would be plus A. So there did need to be a 1 in the last part of the parentheses. So this is my first answer, A times AB squared plus 1. Number 6. If I look closely, do I have a greatest common factor? Is there a number that will go into 9 that also goes into 25? No. No number goes into 9 and 25. But I am noticing that these are perfect squares. There are the perfect squares on the board. We also have a times table where I gave you a chance to see the perfect squares. They're right down the center of that times table going diagonally. So I believe if we look at squares, squares do factor into two sets of parentheses. 9m squared is actually 3m times 3m. That's what makes it a square. It's the same thing times itself twice. So one of the 3m's goes in the front, and the other 3m goes in the front of the second parenthesis. The last part is 25. How do I break up, or how do I factor 25? Has to be the same thing times the same thing, and that's a 5. So one 5 goes in the first, the other 5 goes in the second. I do not have a middle term. This is the one where you just have to remember that these two parentheses are almost the same thing, but one's minus and one's plus. Okay? If we did the check step, I try to emphasize it. If you check it, multiply the two things that are on the inside, the inners. Negative 5 times 3m is negative 15m. Okay, 15. Multiply the outers. 3m times positive 5 is positive 15m. So if you have a positive and negative, that's when they cancel out, and I had no middle term. That mental check step is kind of an important thing to let you know if you get it right or not. Number 7, if I double check, no GCF. So I'm going to go straight to factoring trinomials. I do notice it has 1, 2, 3 terms. So I'm going to do a trinomial. I know x squared factors into x times x, so that goes first and first. I'm also going to utilize an x puzzle. This is something we learned about in class. The negative 40 goes on top, and I'm going to remind myself that I'm supposed to multiply to get negative 40. Okay? And the middle number, negative 3, goes in the bottom of the x puzzle. I'm going to have to add two numbers to get negative 3. Now, if I solve the x puzzle, there's also a clue. If the last term is negative, I'm going to mentally subtract to get 3. Well, let's just remember, what does multiply to give 40? Well, it's going to be 1 times 40, 2 times 20, 3 doesn't go, 4 times 10, 5 goes 5 times 8. I think that's it. Those are the factors that give me 40. Now, which set of factors are going to have a difference of 3 or subtract to give me 3? 5 and 8. So it's going to be 5 times 8. Now, remember our what we talked about says the middle term, the bigger number wins the sign of the middle term. The bigger number is 8, so 8 needs to be negative, 5 is going to be positive. I have solved my x puzzle, which helps me solve my factoring problem. X plus 5, x minus 8. To continue, number 8. Again, do we have a GCF? No GCF. So that means I do not have one set of parentheses. Let's go to 2 sets of parentheses. So this is a trinomial. So now I'm going to factor the trinomial. X and x, okay. And I'm going to do the x puzzle. That's positive 18 on top, and I've got to multiply two numbers to get positive 18. Negative 11 on the bottom, and I'm going to add to get negative 11. Now, as a little clue, if the last term is positive, we're going to mentally add to get the number. So let's factor 18. 1 times 18, 2 goes into 18 times 9, 2 times 9. 3 goes into 18 6 times. I think that's it. So in this case, I am going to mentally add to get 11. 2 and 9, add to get 11. But they don't just add to give 11, they add to give negative 11. So I think that takes a negative 2 and a negative 9. Remember, if the last term is positive, you're going to add. So I have to have the same sign. So negative 2 and negative 9, and that's my answer to the x puzzle, negative 2, negative 9. It doesn't matter which parenthesis is written first. So I think I said negative 2. I ended up writing negative 9 first. No big deal. Another trinomial. Oops, sorry. We have a trinomial, but we must look carefully. If we look closely at number 9, do we have a GCF? Yes. There is not a number that goes into x to the third, 4x, and 5, but there is a common factor, and that is x. They all have an x. Well, what's the most number of x's they all have? This one has 3. This one has 2. This one has 1. It looks like we should be able to factor out 1x from each part, right? So that's where x comes from. So I'm going to have 1, 2, 3 here, 1, 2, 3 parts, minus, minus. I did not factor out a negative, so the signs stay minus, minus. All right, x goes into x to the third. So basically, it's almost like you're saying x to the third, divide out x. Negative 4x squared, divide out x. Negative 45x, divide out x. When you look at it that way, it does look like a divide problem, and you'll still figure it out. The x on the bottom cancels out one of the x's here and leaves me with 2. That's where x to the second comes from. In the next part, okay, x on the bottom cancels out one of these and leaves me with 1. There's a 4 and an x left in the middle. The last one, the x's cancel. Nothing left as far as x goes, but there is 45 left. So when I say that factoring is just the opposite of multiplying, it's dividing, this is another way to look at it. This right here, okay? I think I did that with a couple of students, but if I hadn't shown it to you, maybe it will help. All right. When I look closely at what I have, I notice that inside my parenthesis, I actually have a trinomial. So we did some where we factored them twice, where we factored completely. So in that case, we're going to bring this down. And now my trinomial will break down into 2 sets of parentheses. So x just comes down. X to the second factors into x and x. I'm looking for 45. Negative 45 is what I'm going to multiply to get. And I'm going to add to get negative 4. All right. So I'm solving my x puzzle. I do remember that there is a clue that if the last term is negative, you're going to actually mentally subtract these. So which numbers mentally subtract? Well, I need to make a list. 1 times 45. 2 doesn't go. 3 goes 15 times. 4 doesn't go. 5 goes 9 times. I think that's it. So which ones subtract to give me negative 4? It's going to have to be a 5 and a 9. Now remember, the middle term, the bigger number wins the middle sign. So that's going to make a negative with 9 and a positive with 5. If you hide the bottom, it's almost like you hide the bottom, okay? And positive 5 times negative 9 gives you negative 45, okay? That's what you get if you hide the bottom. What if you hide the top? Now, positive 5 plus negative 9 is negative 4. That is the final solution to my problem. This one factored twice. First time with 1 set of parentheses, and the second time with 2 sets of parentheses. All right, number 10. First thing we always look for is GCF. Now, is there a number that divides into 12 that also divides into 27? Yeah. Do they have a letter in common? Yeah. So I'm going to build my frame first. 1 big set of parentheses. 2 parts means 2 parts inside. Subtraction in the middle. There's a really good chance that this one's also going to bring that factor down and go to 2 sets of parentheses. So if this time, if you'd like to try it yourself, pause the video, see if you can factor it, and then go ahead and start the video and see if you got it right. I'm going to continue. Turns out 3 goes into 12 and 3 goes into 27. So 3 is my number, and they both have 1A in common. So I'm going to divide the numbers, and I'm going to subtract the exponent. Okay? So when I take 3A into 12A to the third, I'm going to get 4, and then A from A to the third leaves me with A to the second. Okay, 3 divides into 27 9 times, and A cancels out A, and it divides it out, and I do not have any A's left. Okay, 3A is just going to get written down. That's my GCF. But if I look closely, this does factor 2 times. So remember, we're factoring as far as we can, what we call factor completely. Okay, 4A squared is 2A times 2A. So that'd be 2A times 2A, and that's going to be minus 3 and plus 3. Okay, that's it. All right, let's go to the next page. Solving for x. Solving for x, now you'll notice that we still have a quadratic, but we actually have a quadratic that says equals 0. So here we go. I'm going to factor the GCF first. So if I do a GCF first, I'm going to take out a 2. I'm going to divide a 2, and if I do, I get x squared minus 9. Now, I'm looking for possibly 2 answers. So when I look for possible 2 answers, I'm going to have to factor this, split it, set each factor equal to 0. You have those steps in your notes. So this is a square, and this number is also a perfect square. So I can take 2, and actually I can discard the 2 because I won't be doing nothing else with it. X squared factors into x and x. 9 factors into 3 times 3, and because there's no middle term, one's plus and one's minus. Now, that's factoring it, but I still haven't solved it. Remember, if I'm multiplying one thing times something else and the answer equals 0, 0 must have come from one of those 2 parts. So I'm looking for 2 answers that would make this be 0. The first number, take what's inside out, so I'm going to take out x plus 3, set that equal to 0. Now if I move x, or to move to get x by itself and move the plus 3, my answer turns out to be negative 3. Take x minus 3 out of this parenthesis, set it equal to 0. If you move minus 3, it becomes positive 3. So my 2 answers when I solved are x equals negative 3 and x equals positive 3. Okay, the first thing that you're supposed to do is to make this say equals 0. Number 12 does not say equals 0. So I'm actually going to have to do something. I'm going to have to move 10x over here, and I'm going to have to move 21 back over here. So if I bring both of those to the left-hand side, it's going to change the sign. So x squared was already on the left-hand side. Move 10x, it becomes negative 10x. But if I move subtract 21, if I bring minus 21 over here, it's going to end up being plus 21 when it comes to the left. And now there's going to be nothing over here but 0. Okay? So when you move across the equal sign, you've got to change the signs. Okay, this factors into 2 sets of parentheses, x and x, 7 and 3. 2 numbers that multiply to give 21, that add to give 10 are 7 and 3, but they have to add to get a negative 10. So I need a negative 7 and a negative 3. Now, I'm going to split between the 2 factors because I'm looking for 2 possible answers. Take this part, pull it out, set it equal to 0. Minus 7 goes over, and it becomes positive 7. X minus 3 equals 0. Subtract 3 goes to the other side, and it turns out to be positive 3. The last one. First thing I have to always do is make sure it says equals 0. This doesn't. It says equals 30. So if we bring 30 to the other side, bringing 30 over here means it's going to become a negative 30. Now I already have negative 10 on that side. So when I take away 30 from both sides, I end up with equals 0. But what's negative 10 and negative 30? Well, negative 10 and negative 30 add to give you negative 40. Okay, you still have 3x and you still have x squared. So my problem now becomes x squared minus 3x minus 40 equals 0 because we had to bring the 30 over. This is going to factor, and I'm thinking of everything that gives me 40. And because it's negative 40, I know I'm going to mentally subtract to get 3 in the middle. And I'm going to make a list of factors of 40. 1 times 40, 2 times 20, 3 doesn't go, 4 times 10, 5 times 8, I believe. So which set of factors subtract to give me 3? Well, it's got to be the 5 and the 8. So if we do a 5 and an 8, we're trying to get negative 3. The bigger number wins the middle sign. Bigger number is 8, so 8 is negative, negative 8, positive 5. That's the way it's got to be to make it work. Now, I'm going to erase my X puzzle and my solution, split this and solve it, and many of you are figuring out that just because you have it in parentheses, it changes the sign when you solve it. Because remember, you got to move it over to the other side. So minus 8 becomes positive 8, and plus 5 becomes negative 5. All right? Number 14. So this is a good way to review everything we've done. If you're having questions, make sure you go to your notes and look up what you have. State the y-intercept of the graph, whose equation is. Now, the thing about it, the y-intercept is the number at the end with no x. You just got to know, okay? So which number at the end has no x? Well, x squared has an x, 5x. The number at the end that we're talking about is what? -6. So the y-intercept is the number at the end, which is -6. Just got to know how to find that. All right. State the x-intercepts of the graph whose equation is. State the x-intercepts. State the x-intercepts. Right now is a good thing to jump down here and just fill this in before we finish 15. X-intercepts is another way of saying find the solution. Well, how do you find the solution? You solve, because you have that solve and the solution. Those are the same thing as the x-intercepts. Those are the same thing as what we call roots of the equation. Some textbooks really like the phrase roots. And we're always going to be setting it equal to 0, so they're called zeros. They're the things that make the equation become 0. So I'm going to pull this equation. I'm going to pull it over here, and I'm going to say 2x squared minus 4x plus 2, and I'm going to set it equal to 0. And then I'm going to solve. Because when I solve, I'll have two possible answers for x, because I am looking for the x-intercepts, which is the same thing as solutions, roots or zeros. Okay, 2x squared. I notice I have a 2 in every number. So I'm going to factor out the GCF of 2. So factor out GCF of 2. Okay, x squared minus 4x plus 2. Oops, getting ahead of myself. 3 blanks. Remember to divide out the 2. Divide out the 2. 1 x squared is left. Divide out the 2 in the middle. -2 with x. And divide out the 2 at the end plus 1. Now, I need to factor the trinomial again. And typically the 2 is not an answer, so I can disregard it. X squared is x and x. And I'm trying to figure out what multiplies to give 2, or excuse me, multiplies to give 1, that's going to add to give me 2. Well, I believe the only way you can get 1 is 1 times 1, so it's got to be a 1 and a 1. But it has to add to be -2. That means it has to be -1, another -1. When you solve, what do you notice about the two parentheses? They're exactly the same. So if you do x minus 1 equals 0, don't forget to move the 1 over, so subtract 1 when you move it over becomes +1. That one turns out to be what? The same exact thing. So that one means this one only has one x-intercept, and that is located at x equals negative or +1. All right, that is the study guide for the test. It's a way to review all the things we've done, from multiplying to area to GCF to factoring. Everything is included here. So I'm going to leave this to you. Good luck on the test. I'll see you tomorrow.